Today I am now going to discuss how to obtain minimum number of bound state and minimum depth or minimum number of bound state and minimum depth of potential well or energy of that finite potential well that I have started in my previous video. Today I am going to discuss that continuation of that portion, minimum number of bound state, and how to obtain energy of the finite potential well. Today I will discuss about that. So let's start discussion. Let us do quickly recap what we have studied in our previous video. We have studied that in case of finite well, full finite well, I am not discussing now truncated. I will discuss truncated in my next video. I am now discussing finite well. In case of full finite well, what was that condition? In case of full finite well, first we have got there are two f function. One is even, another is odd. Why? Because even potential means what? Even potential means Hamiltonian will be also even. Hamiltonian even means what? Hamiltonian even means that parity will commute with Hamiltonian, and what? That wave function will be either even or odd. So for in case of even wave function, what we got? We have got three things: P, 10, P. Let me write in another slide. We have got for even wave function. P 10 P equals Q. This is property number 1. Second property what we have got, that here P is beta L by 2, Q is alpha L by 2. Third property what we have got, third property is P square plus Q square equals R square. And another thing is R is what? R is mv0 L square divided by 2h cut square. Okay, and now what alpha and beta was? Actually beta equals root over 2m e h cut square, and alpha equals root over 2m v0 minus e, if v0 greater than e, in that case, by h cut square. 2m v0 minus e divided by h cut square. Okay, let's start discussion. But how we can obtain the ground state? Firstly, let us discuss about this equation. This was a transcendental equation, and the method to solve the transcendental equation is either numerical solution, another is graphical. So let's discuss about the graphical solution of this transcendental equation. Graphical solution. So the method for solving this this transcendental equation by graphical way is, here draw Q and here draw P. Okay, let me write it clearly. Here draw Q, here draw P. Okay, now here just sketch the line. Okay, let me change the pen color. Actually that will be good for you. Let me change the pen color. So now we will draw the p values. P values are, here we will draw p equals pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2. This is pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, and so on. Okay, so what we will get, suppose now here it is for even bound state, and here it is for odd bounce set. Even, here odd. So in this way, here even we will get even bounce set. Sorry, let me clear it. Here we will get even bounce set. Next, in the next we will get odd bounce set. Even, odd, even, odd, even, odd. In this way we will get even and odd bounce set. So this is the actually the graph. So now let's describe the graph. What is the graph is actually? Graph is actually, see, here we are getting the p values. P values means here pi by 2, here origin 0, next is pi by 2, next is 2 pi by 2 means pi, next is 3 pi by 2, next is 4 pi by 2. Within 0 to pi by 2 region, and suppose here it is within 0 to pi by 2 region, and here it is the radius. Radius means r. It is r. So let's describe this graph. It is even, it is odd, even, odd, even, odd. In this way it will go on. So in the region 0 to pi by 2 we will get what? In the region 0 to pi by 2 we are getting one even bounce set. In the region 0 to pi by 2 we are getting one even bounce set. Similarly, in the region 0 to 2 pi by 2 means 0 to pi, we are getting one even bounce set, one odd bounce set. And within the region 0 to 3 pi by 2 we are getting two even bounce set, one odd bounce set. So how to calculate it actually? Actually there is a trick to calculate it. Suppose two bounce set. Suppose we have two bounce set. Okay. Suppose we have two bounce set. Trick to calculate the number of bounce set in the region. Then what will be the minimum? Suppose in the finite potential well we have two bounce set. So we will write r. Here we will write 2, and here we will write 2 minus 1, 1. Here we will write pi by 2. Here we will write pi by 2. That means within pi by 2 r pi. In this region means pi by r value means radius. Within the radius of pi by 2, within the radius range pi by 2 less than r less than pi, we will get two bounce set. Let us clear it properly. Suppose we have one bounce set and we are trying to discuss that what will be the minimum depth. Suppose we have one bounce set. Okay. Suppose in a finite potential well we have one bounce set. So suppose someone is asking you that what will be the minimum depth of the potential well, then what you will say? How to obtain it? Or what is the range of radius r? So to obtain it, first let analyze the graph again. First you will do what? You will draw that graph again. Here p value, here q value. You will draw that line also of that p value, 1, 2, 3, 4, 5, so on. Here 0, pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, 5 pi by 2, and so on. Now you will draw the bounce sets. Bounce set means one. What? Here even bounce set. First within 0 to pi by 2 region even bounce set. Then pi by 2 to 2 pi by 2 means pi region, odd bounce set. Again here it is even bounce set. Here again it is even bounce set, and in this region in between it will be odd bounce set. Even, odd, even, odd. Even bounce set, odd bounce set. Even, odd. Even, odd. In this way it will go on. Now what we will do, here it will be a radius r. Suppose it will penetrate in the, it will intersect in this region. So number of intersect is here 2. So there will be two bounce set here. So from the graph we can see that if the radius is such that it is intersecting it is intersecting these two lines. Then two intersect will describe that two bounce state. Means here it is radius r, means we are drawing the graph firstly. After drawing the graph, we will see that the radius, we will draw that radius. The radius will intersect how many bounce state? Radius have intersected two bounce state. Here one even bounce state, one not bounce state. So within the radius 0 to pi, means pi by 2 to pi, there will be one even bounce, 0 to pi, there will be one even bounce state and one odd bounce state. Minimum number of bounce state 2. Similarly, let us draw another radius. Here we are drawing another radius. Okay. So how many intersect it has done? So it has done one intersect, second, third, and here it is fourth. Okay. This means it has four bounce state. So in this way, we will see that it is from the graph we can obtain the number of bounce states, and from the number of bounce states we will obtain the minimum number of depth and energy. So how to obtain minimum number of depth and range of that bounce state? How to obtain that range of the bounce state or limit of the bounce state? How to obtain it? So let's discuss that range or limit of that bounce state. Suppose we have one bounce state. So how to draw it? One bounce state means, the trick to obtain that one bounce state is, suppose you have one bounce state, write it here r, write here 1, and write here 1 minus 1, 0. Here 1 into pi by 2. So the range of one bounce state will be 0, r, pi by 2. So the general form of obtaining the bounce state is, so I am going to write the general form of range of that bounce state. So here it is r, here it will be n, here it will be n minus 1, here it will be pi by 2, here it will be n minus 1 pi by 2. So this is the general form of obtaining the range of that bounce state. N minus 1 pi by 2 less than L less than n pi by 2. So here putting the values of n, we will discuss the range of the bounce state. Suppose n minus 1 pi by 2 less than r less than n pi by 2. Suppose we have 3 bounce state, n equals 3. So what will be the range? Range will be 3 minus 1, 2 pi by 2 less than r less than 3 pi by 2. That means within pi less than r less than 3 pi by 2, we will get 3 bounce states. So in this way we can easily discuss the number of bounce state and the range of the bounce state. And how to obtain the minimum of the potential? To obtain the minimum of the potential, minimum depth of the potential, minimum depth. So obtaining minimum bounce state means, suppose we have one bounce state. Okay, suppose we have one bounce state. So how to obtain minimum depth here? So minimum depth means, let's discuss. For one bounce state, how we can write? We know that n minus 1 pi by 2 less than r less than n pi by 2. So put it here, n equals 1. So 0 less than r less than pi by 2. So 0 less than r less than pi by 2 means we can write it here 0 less than root over mb0 L square by 2 h cut square less than pi by 2. Now do the square here. 0 less than mb0 L square by 2 h cut square less than pi square by 4. So the minimum depth of the potential will be mv0 L square by 2 h cut square equals pi square by 4. Here it will be 4. So from here we can easily obtain the minimum depth of the potential. here we will get the V0. So in this way, 0 mv0 L square by 2h cut square less than pi square by 4. In this way we can obtain the minimum, the range of that minimum depth. So this is the thing that we have discussed today. That's it for today. Thank you for patiently watching this video. In the next video we will do lots of things to discuss, lots of more things to discuss in the finite well, because it's very important thing. It's very important thing, and we will discuss lots of more things in finite well. Today we can't discuss the energy, how to obtain energy value, and this is a thing what we learned today. So let me do the conclusion what we learned today, that whenever we will do that minimum number of bounce state, we know that for even bounce state P tan P equals Q, P equals beta L by 2, Q equals alpha L by 2, P square plus Q square equals R square. These all things we don't know. So what we have learned today, for obtaining the minimum number of bounce state, we have the relation in case of full finite well n minus 1 pi by 2 less than R less than n pi by 2, where R equals mv0 L square. L means width of the finite well divided by 2h cut square. L width of the finite well. That we have learned today. So thank you very much for patiently watching my video. Okay.